Welcome Algebra 2. We're doing our first brand new lesson of new math from this video making process. So we're trying to learn how to do homework problems from set 9.1, which is on 386. There's a companion paper of notes on this. But before we do that, I'd like first to give special appreciation to John and Jerry's Fruit Market. John and Jerry's Fruit Market during this difficult coronavirus time is the official sponsorship and provider of potatoes for TMR the Math Wizard. So we'd like to thank them for their help and support on the potato provisions for the TMR the Math Wizard.com YouTube channel. So 9.1 starts off asking you first about whether it is, there's a thing called symmetry that you might know about, just that's a life word if you have a lot of vocabulary words. But there's two ideas they start off asking you on 386, which is whether something is symmetric to a line or whether it's symmetric to a point. So on our notes paper, it explains that symmetry to a line occurs if there's 2 points that are the same distance away from the line. So I drew you some stuff here where these 2 points are, if I could draw, all assumptions here are that I could actually draw, so you base your judgments that way. If I could draw, this point is the same distance away from the line as that point. So this picture, I would say, yes, that is symmetry to the line. If I had thrown this point way over there, I would say no, because this is a little ways away and that's a long ways away. If I threw one up here, I would say no, because that's just not the right thing. They have to mirror each other across the line. Imagine you had a piece of paper and this drawing was the place where we would fold that paper. If this were wet ink and this is a piece of paper and we folded and pressed, this wet ink would leave a new spot over there that would mirror each other across that line. And that's what we're looking for to say yes. On a bigger picture, if there's more than just a single dot, there's a bunch of stuff. We need for every point to have a mirroring partner. So like this point mirrors that one. This point mirrors that one. Any point I pick on one side has a mirror on the other side. If we imagine this were wet ink and we folded and pressed, this side would create that side. So we're saying yes there for symmetry to a line. This is a no. This point would need a partner over here, and it's not there. This point would need a partner over here somewhere. It's not there. If we folded this across and pressed, we'd get a thing like this, where my hand is. We wouldn't get that. That's a no. This would be a yes. Fold and press. Yeah. This half of the circle mirrors the other half of the circle. This square mirrors that square. I'm saying yes. That's the first concept. Second concept is whether it's symmetric to a point. Okay, so to be symmetric to a point, there's a paragraph farther down on the page. We have to have, again, the 2 points be the same distance away, but they have to lie on a line. So, I erase my questions, my answers. What I would have to do is improve my drawing by adding one to my drawing. So before I didn't need this, now I need another feature in my drawing. If I put this dot on here, the question is, are these the same distance as those, and do they all line up? Yes. If this were up here, are these the same distance away? Yeah. But do they all line up in a line? No, they don't line up in a line. If this were my point in my original drawing, the partner for this would have to be like up there somewhere. Now these are the same distance away, and they all line up. So if I step over here, pick any point that exists, I would have had to have drawn this previously. So here I go, improving my drawings slightly. Improving my drawings slightly. Pick any point, go to here, and stay in a line and keep going. Okay, right about there would need to be where the partner is, and that's empty space. So this is a no. this point, if I try to go through here, same distance out the other side in a line, no, I can't do it. Pick any point of this anywhere. Here I go through here, out the other side. If I could draw, this would be the same distance as that, and I did pretty well there. All of that lines up, anything has a partner over there. If I went high, came through here and kept going, I'd find a partner over there. If I had picked this, gone through there, there's a partner. Any point that I pick, it's going to have a mirroring partner, so I would say yes there. Circle, pick any point, go through, keep going in a line. If you find a partner anywhere, that is a yes. Squares, pick any point, go through there, out the other side, we'd be good. We'll pick a far corner, go through there, same distance through in a line, we'd be there. I'm saying yes on that. Had I tweaked the original drawing and done the point up here, now I'd say no. Because if I picked this corner, went to there, and then stayed in a line to keep going, I land in the middle of a wasteland of empty space, now I'm back to a no. So that's the first homework thing, 1 to 6, now we're on it. 7 to 10, they're going to have you do a little bit of graphing. You don't necessarily need graph paper. You can just do a little sketch like I'm doing. But they'll tell you, here's a point like 3, 2. Over 3, up 2. And they're going to want you to create, here's our second call into the show. We'll have to pause and see who this is. And we're back. That was a small emergency from home. A bookshelf fell down somehow. Things scattered everywhere. So that was a young boy calling me to ask what he should do. And I told him, pick up the stuff, put it in the piles, figure it out. No one was harmed, so don't worry about the young boy. Symmetry, okay, so symmetry to the x-axis, they'll give you a point and they'll want you to figure out whether we have symmetry to the x-axis. So symmetry to the x-axis, they're going to want you to draw something, symmetric to the x-axis. So this is the x-axis. We're going to use that x-axis like I was just using this mirroring line here. So instead of being above that line a little bit, we're going to have to throw a dot below it. And this would be the location 3, -2. And we just bumped into an important idea here that when you have symmetry to the x, the y's are going to be opposites. So if you look at your paper there, it describes that. Symmetry to the x-axis is that the y switches sides. Symmetry to the y-axis would be the opposite thing, which is focusing on this line and folding that way. So we would end up over here, about like so. That would be at -3, +2 now. These guys are symmetric around the y-axis. And we just bumped into an important idea that symmetry to the y-axis means that x's are going to be opposite. So if your symmetry to the x, look y. If your symmetry to the y, look x. So here's the ruling on if they start to give you equations. So 7, 8, 9, 10 are going to be sketches like this, where you're doing a symmetric point to match a partner. Then on 11 to 22, they give you a bunch of questions and ask you, is it symmetric to the x? Is it symmetric to the y? It could also be both. It could also be neither. So here's the ruling. Symmetry on the x-axis, you look at the y. And as the notes describe, what you try to do is think about, if you switch the sign of the y, would the problem be the same or different? On this problem, if you switch the sign of the y, the problem would be different, because we would have switched the sign. So this would not have symmetry to the x. So x-axis symmetry, no, because the y failed us. And some people are thinking, wouldn't it always switch the problem if you switch the sign? And the answer is no. If we're going to go test the symmetry to the y, we'll look at the x. If you tried to switch the sign of the x, think about what would happen. You try to switch the sign of the x, which is being squared. The squaring won't let you switch the sign. Squaring guarantees you positivity. So if this were positive, you get a positive. You try to switch it to negative, you still get a positive. The squaring won't let you do that. So if you did try to switch the sign with the x, the squaring would erase your change. Since we were looking at x, that actually gives us a y answer. Like we were talking about over there, x symmetry switches y symmetry switches x. The y symmetry would be a yes. So we'll go again. It's the same process every time. If we want to test x, we look to y. This y, if we tried to switch it, we'd switch it. Because there's nothing there to prohibit our switch. So we again say no. For y's switch, we look at x. An even power forces positivity on us. We can't switch the sign. Everything would remain the same. So we'd say yes. Again, for x, we look to y. And this time we have bars. The bars would not permit that change. Bars guarantee you positivity. So for the x, we would say yes. And for the y, we would continue to say yes because we keep getting even powers on the x's. Long story short, if one of the letters has an even power or bars, say yes toward the other letter. So x, x, x evens. So y, yes, yes, yes. When we want to judge x, we look to y's. The only thing that did anything with y's was the bars. The bars made that be a yes, but the others were no's. I'm done with the front now, and you should be okay. Homework stuff up to 22. Then there is another drawing thing. They want us to go symmetry to the origin. So I'm going to erase this. And we're going to bump into another idea. If we go symmetry to a point, with that point being the origin, these are the ones we did a minute ago where we need to travel in a straight line. You travel, 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 keep going in a straight line, travel, travel, travel. Partner would be there. And we get -3 and -2. For symmetry to the origin to happen, we have to have both x and y swapped. So on your drawings, that should take you to 26. Then they give you a list of problems to test for symmetry to the origin. So we're going to try to change both of these. Try to change both of them. But since they both have squares, both things remain the same. Everything remains the same. If everything remains the same, say yes. On this, if we try to switch them both, nothing prohibits those changes. And we would actually switch everything. Switching everything, ironically, is still a yes. Because if we do something on one side of the equation, but we do the same on the other, it's still the same equation. We didn't really make a change. We changed the way it looked, but not really changed its heart. So nothing changed? Yes. Everything changed? Yes. This is going to be a no. Because if we start to do changes here, the x would flip signs if we flipped it. The y would not flip signs because the even wouldn't let us flip signs. The 11 won't let us flip signs. So this, when some switches and some don't, we're saying no on that. And that's the idea of getting us from 27 to 38. Then some of these words have synonyms. If I ask you about the word even, even means the same thing as symmetry to the y, and that's on the back of the paper. So if I went back here and redid any of these and said, is this one even? Yes. Is it even? Yes. Is it even? Yes. Symmetry to the y is the same as me asking if it's even. If I ask you if it's odd, that's the same as symmetry to the origin. So if I did redid these questions and just retitled it, does it have symmetry to the origin? It doesn't change your answers any. They will present this section of answers though to you in a different form. So I'm now looking from 39 to 50. From 39 to 50, they're going to write every time f of x equals, f of x equals, f of x equals. I was too lazy to write f of x equals every time. That might not be to your liking, but some of you might remember, if they don't say f of x, that's the same as them saying y. It's the same thing. Doesn't make any difference. And if they write them this way, I have a shortcut to you. Everything I said over there was true, and it's the way you had to do it. But we can shortcut these if the choice is even, odd, or neither. All you have to do is look to the powers. If you have all even powers, say even. If you have all odd powers, this invisibly, remember, has a 1. If it has all odd powers, say odd. If it has a little bit of each, some even and some odd, then you'd say neither on that. This problem, invisibly, numbers have an x with a 0 power. You might remember anything to a 0 power is 1. 1 times things is harmless. Any plain old number, use your imagination that it has an x to the 0. So 2 and 0 are both even. This 5 has an x to the 0 invisibly, so even. This is different. We have to go back and rethink what this meant. Okay, so even meant symmetry to the y, which meant we were looking at the x and seeing what x did. And on bars, if the x is in bars, the x would never be willing to change signs. The bars would refute that. So this is a symmetry to the y, yes, just like we had over here a minute ago. So symmetry to the y means even. This is therefore a neither, because this is an even kind of thing that we just decided. This is an odd, because it has a 1, so that's a no-go. Retreading a step. Any number they give you is going to be called an even function. I'm not talking about even numbers and odd numbers. There's a thing called even functions and odd functions, and that's different. So 5 was an even function, even though it's not an even number. If I said 6, still even. 7, I say even. I say 3.174, it's even. I say any number in the universe, it would be even, except in a bit of small trivia, if I say 0, the only thing in the universe that I can say both odd and even is 0 itself. 0 is always weird. It takes forever to upload these videos, so I'll spare you the lengthy explanation on that. If you care, see me in person sometime. But 0 in a bit of trivia is both even and odd. Then the last thing of homework is they drew pictures and they want you to make these same judgments. So again, even means symmetry to the y. So this picture, because it mirrors each other using the y-axis as that fold line, that mirror line, this would be a graph of an even. This does the same thing. That V creates a little mirroring situation, the wet ink and all that, press it down like we were talking about at first, that would be even. This is not even, because this would need a partner there that it doesn't have, so not even. This would need a mirror over there, so also not even. But maybe they're odd, maybe they're nothing. Okay, to be odd, odd is a synonym from a minute ago on the notes, to be symmetric to the origin. First Algebra 2 chalk break to the video career, so landmark again. We have to imagine the origin is our point. Pick anything, go through there, stay in a straight line, find a partner, that seems good. Try again maybe to be safe, pick a point, through there, find a partner, yeah, it seems like it's going to work. So this would be an odd, because that game worked. This, pick any point, go through there, can we find a partner? Yep. Go there instead, through that, staying in a line, find a partner, yep. Everywhere you go you find a partner, that is also odd. Those can't be odds, you're either odd or even, pick one, not both. The only thing that's both is 0, and if I graphed your y equals 0, it would be just a flat line graph like that. They're not going to do that in the homework. So this last group, it's either even or it's odd, or maybe they're neither. If they weren't matching up right either way, neither is a choice, but both is not. There are some neithers in the homework from 51 to 58, and that is our lesson for today.